Have you ever stared up at the night sky and wondered what lies in the deepest, darkest patches between the stars? What if there are places where space itself collapses and the rules of reality break down? An object so dense, so powerful, that it consumes everything, even light. This boundary is the event horizon, the point of no return. It marks where outgoing light can only skim along the surface, never escape. A black hole warps space-time itself. Imagine stretching a rubber sheet and placing a heavy bowling ball in the middle. Roll a marble nearby. It follows the curve. A black hole is like a well without a bottom. Near the event horizon, every path points inward. How big is this boundary? The Schwarzschild radius is given by r equals 2gm c squared. G sets gravity's strength. M is black hole mass, and c is the speed limit of the universe. More mass means a larger event horizon. It is a prison for light. The horizon is not a surface, it is an invisible mathematical boundary. Cross it and nothing feels different. But escape is no longer possible. It separates the knowable universe from the ultimate unknown. Across this edge, no information, no light, no story can escape. It is the shore of a cosmic ocean from which no traveler returns. For a long time, black holes seemed like eternal prisons. But then in 1974, Stephen Hawking looked closer. Combine gravity with quantum rules and something extraordinary happens. Black holes are not completely black. They glow, faintly. Empty space seethes with pairs of virtual particles. Near the horizon, one can fall in while the other escapes. To us, it looks like the black hole emitted a particle, Hawking radiation. Hawking showed black holes have temperature. The more massive the black hole, the colder it is. A sun-mass black hole is about 10 to the minus 8 Kelvin, around 0.0000006 K. Colder than the cosmic microwave background, so it absorbs more than it emits. As mass drops, temperature rises and radiation intensifies. Final moments, a runaway blaze, then a flash of gamma rays. A supermassive black hole could take about 10 circumflex 100 years to vanish. A solar mass black hole, roughly 10 circumflex 67 years. Smaller black holes run hotter and evaporate faster. A mountain mass one burns fast. A car mass could disappear in less than a second. Physicists have searched for primordial mini-bangs, none seen so far. Black holes are mortal, born from dying stars and destined to fade. Hawking radiation also sparks a deep paradox. Quantum mechanics says information can never be destroyed. Throw a book in. If the whole evaporates into random heat, where did the story go? Relativity and quantum theory both work, but at the horizon they clash. Black holes force relativity, quantum mechanics, and thermodynamics to meet. Bekenstein and Hawking linked entropy to horizon area. S equals K underscore BC cubed A, 4GH. Hawking temperature, T underscore H equals HC cubed, 8PGMK underscore B. Smaller mass means hotter. Hints like holography suggest information may live on the horizon itself. Black holes challenge what space and time are, and whether information can ever be truly lost. They are a cosmic invitation. A dare to think bigger, push harder, and never stop questioning. Those dark patches, they are full of mystery, challenge, and answers. If the pull of this mystery grabbed you, let it guide you back here. Subscribe to our Universal Universe channel for daily cosmic adventures. Share this journey with a fellow explorer, and give it a like so the stars keep finding you.